So in this particular problem, we have, again, two vehicles colliding, and we're going to find the speed of this vehicle after the collision. Now, I've translated the question into this diagram. I suggest you do the same for all these problems where you have before the collision and after the collision. Each car, the direction, the speed, and the masses. We can go ahead and use our equation. So our equation is momentum before the collision equals momentum after the collision. So again, right is positive in these situations always. Let's look at momentum before the collision. The mass of the first vehicle is 2,200 and the speed is positive 30 because it's going to the right, plus 1,300. Now since the speed of this is negative 60, since it's going backwards, is equal to momentum after the collision. So the mass stays the same, 2,200. Now we don't know anything about the speed after. All we know is when it went in reverse, but we don't need to make this negative because this is unknown. But we do know it's going backwards, so in the end v should equal minus something. You don't put a minus here, the v will be equal to a minus number. Plus 1300 multiplied by, we're told this car comes to a stop, so the velocity is 0. Calculate all of this. Calculate, well, there's nothing really to calculate there, that becomes 0. So find all of this and divide both sides by 2,200. That gives you a velocity of minus 5.45 meters per second. Now the next part of the question asks us to calculate the loss in kinetic energy. So just like before, it's going to be initial kinetic energy minus final kinetic energy. So the initial kinetic energy is going to be half mv for each vehicle. Again, the v doesn't have to have a direction, so we don't put positive or negative, plus half of the car times 60 squared. So that's the initial kinetic energy minus the final kinetic energy. So a half multiplied by the mass doesn't change. Now we know the speed now, 5.45. We just found it, so we know the speed now. Now I'm going to put 0 here because we know the speed after the collision was 0. So it's going to be half m times 0, which makes 0. There is no kinetic energy since it's stopped. Plug all these, so find this first of all, then minus this here. That gives you a value of change in kinetic energy is equal to 3297,272.73 joules. The final part of the question asks us to calculate the magnitude of the impulse of the coupe on the 4x4. So we're modelling the 4x4. The 4x4 feels an impulse in this direction because the car is hitting the 4x4 from here. And to find that, we simply use the equation we did in the last problem. Now, the mass is 2,200 on the 4x4, so I'm modeling the 4x4. The final speed of the 4x4, we calculated here, minus 5.45. Go back to putting your minuses now and pluses. Minus the initial speed, which was 30. This gives you an impulse value of minus 78,000 Newton second.